Hello everyone, today I'm going to be going over the differences between TPUs and GPUs when it comes to computing. So, why don't AI companies use the TPU? This is a question that I was trying to answer, as we'll go over some of the characteristics of the TPU and the GPU in a moment. And when I heard about the TPU for the first time, I was confused as to why AI companies don't switch from GPUs to TPUs. But after some more research, we will go into the reasons that I have found, potential reasons. So, first of all, what is a TPU? A TPU is a tensor processing unit. We're very used to graphics processing units, or GPUs. And a TPU is essentially a more specialized version of the GPU that's built specifically for machine learning and AI. So it's optimized for these tensor operations like matrix multiplication. And if we think about it, GPU, as we think of it, is really a GPU, or a general purpose GPU, as you can use it for a wide variety of applications like graphics rendering in your games, parallel processing, tensor operations like TPUs excel at, and much more. So a TPU is basically a GPU that's not meant for anything except machine learning and AI applications. So, looking at a baseline performance comparison, we can see a study that was performed on the human activity recognition data on an LSTM model done on Google Collaborate, which is Google's cloud hosting service. And we can see that if we look at the runtime over layers, we see a much more consistent speed up or slow down, sorry, of the TPU as the amount of units and the amount of layers increases. Whereas for GPU, we can see that that starting time at 8 units, if you look at the gray and orange lines in the second from the left graph, start a little bit lower at 158 and 166, but then rise much quicker. And at 256 units, if we look specifically at the gray line or the 4 layers, then we can see over 600, whereas for the TPU, its runtime is just about 430. And then if we take a look at accuracy using a TPU and a GPU, you can see that on the GPU, the accuracy is kind of spread out. Sometimes certain even more layers performs better, or sometimes it performs worse, and it's very hard to predict. Although the runtimes do end in a similar sort of area to the TPU, or the accuracy, we can see that the TPU has a much more curved and predictable performance metric, even though the lines sometimes cross over each other. We can see that TPU generally has not only a more predictable performance, even though accuracy isn't benefited much, but it definitely has an increase in the performance when it comes to the runtime over the GPU, especially when you increase the amount of computation that needs to be used, because TPUs are more specialized, so they're going to be slower at, as you can see, where 8 units, but faster at 256 units. So more computation benefits the TPU. Continuing with performance comparisons, we can see a general comparison that another study did between a CPU, a GPU, and a TPU. And this kind of gives the general layout that I described earlier. CPU controls instructions, a GPU is specialized for rapid calculations that are heavily parallelizable, and a TPU is specific for AI. And you can see some of the applications listed in the table on the left. And when looking at the performance, you can see that the difference between CPUs and GPUs is rather big, as GPUs are able to complete more operations per cycle. But we can see with TPUs, when performance comes to specifically AI machine learning usages, can go up to 128,000 operations per cycle. Um, we also see that the only manufacturer of a TPU is Google, which will be talked about shortly, and the cost might be a little bit higher than that of a GPU of the same caliber. So, in general, as a performance comparison, GPUs work well for general computational purposes. We see a performance over TPU for less computationally expensive tasks, like less layers in that first example. And it's not optimized for machine learning, but then again, it's not supposed to be. GPUs are intended for general purpose computing. Whereas a TPU, it works well for machine related purposes, not well for general computing. And we see a noticeable performance increase over the GPU for larger tasks. It is more consistent runtime and accuracy metrics across trials. And overall, it is slightly, if not mediocrely, more effective than the GPU for machine learning. Now, let's look into another comparison outside of performance. Let's look at a cost comparison. So in my research, I found that One of the most popular NVIDIA GPUs for AI is the NVIDIA H100, rivaled closely by the NVIDIA A100. Various sources, some as low as 20,000, some as high as 50,000, but around the average price for the H100 is around $30,000 per unit. And companies like Meta and OpenAI and Google even buy billions and billions of dollars of these GPU, tens of billions of dollars. If we compare cloud computing prices, the H100 is available for varying prices from $2 to $4. Now, this is cloud comparison is because TPUs are not market available. So we don't have a price for a TPU that you can buy on the market. But if we look at Google's cloud pricing for the TPU V5P, which is the most updated version of the cloud TPU, it's around $4.20 per chip hour. So it is slightly more expensive when it comes to cloud computing, which can be telling of it would be more expensive if it was market available. An additional stat, NVIDIA estimates they sold 2 million H100 GPUs in 2024, and they expect to sell about 300,000 in the first quarter and about 3 million through the first year. So, quite obviously, if we analyze them, TPUs do provide a better performance, but at a slightly higher price. So is there some other reason why they aren't the preference of AI companies? You can see by many of these headlines, shortly after ChatGPT released, NVIDIA's stock price went way up because people are buying their GPUs, especially these tech companies, as you can see, Meta buying them, OpenAI buying them, XAI buying them, Microsoft buying them. Every big tech company is buying these NVIDIA GPUs. So are there other reasons other than performance and price that we can look at? Well, if we look into business reasons why TPUs aren't used, obviously they aren't commercially available. It would be much harder to commercially sell TPUs than to run them on the cloud for Google, as you have a lot of overhead when it comes to selling something. Not only do you have to manufacture it, but there are different safety qualifications and other steps in the process that would have to happen for Google to be able to sell TPUs. Additionally, it would put Google into another market of which they're already reaching into multiple different markets and sort of spreading themselves somewhat thin. It would put them directly in competition with NVIDIA, which is, again, the massive leader in this industry. And Google might prefer its cloud services over selling physical hardware because the cloud, Google can manage it themselves. And if they sell the physical hardware, then other people will have the TPUs available and they will basically make their own competitors to their cloud service by selling the TPUs. Also, not to mention the physical manufacturing that would have to go into produce these hardware, you would need warehouses that can mass produce these things. So, another business reason would be to stick with what's popular. Every tech company, as mentioned before, is buying NVIDIA GPUs for AI. So, if you were looking to start up an AI, why would you do something different? Why would you not buy NVIDIA GPUs? Why would you take a risk and go with TPUs when you could just stick with what's working? And probably the biggest reason is that NVIDIA GPUs are already established and being used, so there's no point in spending all of the money to switch over from using NVIDIA GPUs to TPUs. Because AI takes a lot of money to invest in AI, tens of billions of dollars as mentioned, and from a business perspective, you can't justify throwing away that infrastructure of NVIDIA GPUs just to switch to TPUs, even if they are slightly more effective at machine learning. And another reason why TPUs might not be used is because of the shaky performance increase. So we saw a slight performance increase, but there isn't that much research into how much TPUs increase the performance over GPUs. We would need to invest in this research to see if the speedup is worth it, and companies do not want to invest in that when they can just use NVIDIA GPUs. We would also need access to the TPUs to perform the research, and Google is the only place that makes them. And even then, it's hard to compare TPU to GPU because there are many, many differences to test because one is specialized and one is not. And the question that companies would need to ask is how much price performance trade off is worth it? If the performance increase is negligible for the cost increase, then why would you switch? You need 100% confirmed evidence of a significant performance increase with some sort of cost decrease. Maybe you have to buy less TPUs than GPUs to get the same computational power. And even then, you would still have to rework your existing systems as mentioned earlier. And third possible reason why TPUs aren't used is just because of convenience. GPUs have existed for much longer than TPUs, early 2000s, whereas TPUs were just coming around in the 2016s and 2017. And the systems around GPUs are much more convenient. We've been learning about CUDA, which exists for GPUs. You can code GPUs exactly how you want them using CUDA, NVIDIA CUDA. And this makes TPUs relatively hard to work with in comparison to GPUs. So, like as mentioned, GPUs are commercially available while TPUs are not, and that is a large level of convenience as you would need to get Google to specifically make them for you or develop your own, which is even more overhead. And again, it would be a waste to switch now, so maybe it's too late for companies to already switch to TPUs. So, in conclusion, there are many different reasons why TPUs aren't being used. Business reasons, lack of proper research into performance metrics that show a benefit, and the existing systems that have already been created by these AI companies or just big tech companies in general, they already use NVIDIA GPUs, so why would they throw away their infrastructure? NVIDIA GPUs have CUDA to program them, while TPUs do not, due to them being much newer, and GPUs have just existed for longer. People are more familiar working with them, so you can find people that are already experienced working with GPUs while you cannot find that for TPUs. One thing I would like to point out before the end of the presentation is that the development of CPUs has shifted towards specialized performance for tasks. As we learned in class, CPUs for a long time, these general purpose CPUs kept seeing an increase in performance and then they slowed down recently. And I would like to point out that recently, commercially available NVIDIA GPUs used for gaming, like the RTX 4090 and the RTX 5090, have a much less performance increase than from the 3090 to the 4090, at least when it comes to things that aren't using like NVIDIA DLSS or its other AI performance increasers. So I just wanted to ask the question, is the path of GPUs headed towards specialization just as the path of CPUs has recently? So that's the end. Thank you for watching my presentation.